Let's establish a scientifically grounded set of tools, meaning tools that take into account the identity of the neurochemicals that are important for enhancing learning and the timing of the release of those chemicals in order to enhance learning. When I first learned about the results of McGaugh and Cahill, I was just blown away. I was also pretty upset, but not with them. I was upset with myself because I realized that the way that I'd been approaching learning and memory was not optimal. In fact, it was probably in the opposite direction to the enhanced protocol for learning and memory that I'm going to teach you today. My typical mode of trying to learn something while I was in college or while I was in graduate school or as a junior professor or even a tenured professor was to sit down to whatever it is I was going to try and learn, perhaps even memorize, or if it was a physical skill, move to whatever environment I was going to learn that physical skill in. And prior to that, to make sure that I was hydrated, because that's important to me and certainly can contribute to your brain's ability to function and your body's ability to function and general patterns of alertness, but also to caffeinate. Right? I would have a nice strong cup of coffee or espresso. I would have a nice strong cup of yerba mate. And I still drink coffee or yerba mate very regularly. I drink them in moderation, I think, certainly for me. But typically I would drink those things before I would engage in any kind of attempt to learn or memorize or to acquire a new skill. Now, caffeine in the form of coffee or yerba mate or any other form of caffeine does create a sense of alertness in our brain and body, and it does that through two major mechanisms. The first mechanism is by blocking the effects of adenosine. Adenosine is a molecule that builds up in the brain and body the longer that we are awake, and it's largely what's responsible for our feelings of sleepiness and fatigue when we've been awake for a very long time. Caffeine essentially acts to block the effects of adenosine. It's a competing agonist, so not to get technical, but it binds to the receptor for adenosine for some period of time and prevents adenosine from having its normal pattern of action and thereby reduces our feelings of fatigue. But it also increases state of alertness. So while it's reducing fatigue, it's also pushing on neurochemical systems in order to directly increase our alertness, and it does that in large part by increasing the transmission of epinephrine, adrenaline, in the brain and body. It also has this interesting effect of upregulating the number and or efficiency, or we say the efficacy, of dopamine receptors, such that when dopamine is present and as a molecule that increases motivation and craving and pursuit, that dopamine can have a more potent effect than it would otherwise. So caffeine really hits these three systems. It hits other systems too, but it mainly reduces fatigue by reducing adenosine, increases alertness by increasing epinephrine release, or adrenaline release, I should say, both from the adrenals in your body and from locus coeruleus within the brain. And it can, in parallel to all that, increase the action or the efficacy of the action of dopamine. So my typical way of approaching learning and memory would be to drink some caffeine and then focus really hard on whatever it is that I'm trying to learn, try and eliminate distractions, and then hope, or try to remember that information as best as I could. And frankly, I felt like it was working pretty well for me. And typically, if I leveraged other forms of pharmacology in order to enhance learning and memory, things like alpha GPC or phosphatidylserine, I would do that by taking those things before I sat down to learn a particular set of information or before I went off to learn a particular physical skill. Now, for those of you out there listening to this, you're probably thinking, well, okay, the results of McGaugh and Cahill pointed to the fact that having adrenaline released after learning something enhanced learning of that thing. But a lot of these things like caffeine or alpha GPC can increase epinephrine and adrenaline or dopamine or other molecules in the brain and body that can enhance memory for a long period of time. So it makes sense to take it first or even during learning and then allow that increase to occur. And the increase will occur over a long period of time and will enhance learning and memory. And while that is partially true, it is not entirely true. And it turns out it's not optimal. Work that was done by the McGaugh laboratory and other laboratories evaluated the precise temporal relationship between neurochemical activation of these pathways and learning and memory. What they did is they had animals and or people, depending on the experiment, take a drug, could be caffeine, could be in pill form, something that would increase adrenaline or related molecules that create this state of alertness that are related to emotionality. And they had them do it either an hour before, 30 minutes before, 10 minutes before, 5 minutes before learning, or during the bout of learning, right? The reading of the information or the performing of the skill that one is trying to learn, or 5 minutes, 10 minutes, 15 minutes, 30 minutes, etc. afterwards. So they looked very precisely at when exactly is best to evoke this adrenaline release. And it turns out that the best time window to evoke the release of these chemicals, if the goal is to enhance learning and memory of the material, is either immediately after or just a few minutes, 5, 10, maybe 15 minutes after you're repeating that information. You're trying to learn that information. Again, this could be cognitive information or this could be a physical skill. Now, this really spits in the face of the way that most of us approach learning and memory. Most of us, if we use stimulants like caffeine or alpha GPC, we're taking those before or during an attempt to learn, not afterwards. These results point to the fact that it is after the learning and memory that you really want to get that big increase in epinephrine and the related molecules that will tamp down memory. So what this means is that if you are currently using caffeine or other compounds, and we'll talk about what those are and safety issues and so forth in a moment, if you're using those compounds in order to enhance learning and memory by taking them before or during a learning episode, well, then I encourage you to try and take them either late in the learning episode or immediately after the learning episode. Now, given everything I've told you up until now, why would I say late in the learning episode or immediately after? Well, when you ingest something by drinking it or you take it in capsule form, there's a period of time before that gets absorbed into the body, and different substances such as caffeine, alpha GPC, etc., are absorbed from the gut and into the bloodstream and reach the brain and trigger these effects in the brain and body at different rates. So it's not instantaneous. Some have effects within minutes, others within tens of minutes, and so on. It's really going to depend on the pharmacology of those things, and it's also going to depend on whether or not you have food in your gut, what else you happen to have circulating in your bloodstream, etc. But at a very basic level, we can confidently say that there are not one, not dozens, but as I mentioned before, hundreds of studies in animals and in humans that point to the fact that triggering the increase of adrenaline late in learning or immediately after learning is going to be most beneficial if your goal is to retain that information for some period of time and to reduce the number of repetitions required in order to learn that information.